Welcome to trigonometry. To start off with, we should agree on what we call our triangles. The angles are generally, just by convention, referred to with capital letters. Here I've labeled them angles A, B, and C. Generally, if we're working with right triangles, angle C is at the right angle. We also want to label the sides. Again, by convention, what we do is we label the opposite side the lowercase version of that letter. So opposite from angle A, I name this side lowercase a. That means angle B is opposite side length B, and angle C is opposite the hypotenuse. This works really well because one of the things that we use in trigonometry is the Pythagorean theorem, which of course says that a squared plus b squared equals c squared. And so by naming our angles and side lengths this, we can remain consistent because in the formula, lowercase c is the hypotenuse of that triangle. What is the side that's opposite angle B? Side length B. What is the side that's adjacent to angle A? Well, it appears at first that two sides are adjacent to angle A, but whenever it's asking for a side that's adjacent, they're not talking about the hypotenuse. They're talking about the other leg of the triangle. Just as a quick review, for a right triangle with side lengths A, B, and hypotenuse C, the Pythagorean theorem says that a squared plus b squared equals c squared. And here we have a right triangle, and we want to find the missing side when we know that A equals 12 kilometers and C equals 61 kilometers. So 61.0 kilometers, and then I'm going to call the short side, side A. And what we want to find is the missing side, or side B. We could plug each number into the Pythagorean theorem, but I'm going to take a shortcut here. Since b squared equals c squared minus a squared, so if I just subtract a squared on both sides, I also know that b equals the square root of c squared minus a squared. So I'm going to go directly to my calculator and plug in the square root of 61.0 squared minus 12.0 squared. I've got b equals 59.80802622. Since both A and C have three significant figures and are precise to one decimal place, I'm also going to leave B as precise to one decimal place. This missing side length should be 59.8 kilometers. Where does trigonometry come into all of this? What are the trigonometric functions? They are ratios. Specifically, they're the ratio of two side lengths. And this is so cool because trig ratios connect or relate angles to side lengths. So if we know two side lengths in a triangle, we can also find out the angle. If we know an angle and a side length, we can find out other angles and side lengths. These are the trig functions. We have three primary trig functions, and the next video we're also going to talk about the reciprocal trig functions. Primary trig functions are sine, cosine, and tangent. I know that looks like sin, but it's not sin. Don't call it that. It's sine, and this is cosine, and this is tangent. These are the definitions for each of these trig functions. The input of the trig function, what we're taking the sine, cosine, or tangent of, is an angle. And what it equals is a ratio of side lengths. So the sine of angle A, so from the perspective of angle A here, this is the opposite side. And then the hypotenuse is always just the hypotenuse. So the sine of angle A is the ratio of the opposite side divided by the hypotenuse. That ratio equals the sine of that angle. Cosine of angle A is going to be the adjacent side divided by the hypotenuse. So the ratio of the adjacent to hypotenuse. Tangent doesn't include the hypotenuse. Tangent of this angle A is the opposite side divided by the adjacent side. More on these trig functions in the next video. Thank you.